And here the video number 4 for kinematics. Now since you people are going for holidays, so let's plan 8 to 10 days to how to approach, so you are being a good preparation afterwards. So this is the catalog that you have seen: the distance and displacement and horizontal motion, acceleration, vertical motion, graph, and relative velocity. These are the topics that we supposed to cover, and I'll try my best ki I'll make you conceptually more closer to the article so you can understand, because if the concept is clear, so might be you have not practiced so many questions, even then you can think about the question properly. So today I will surely take few questions, and what I'm planning with nearly 4 to 5 small videos I will post, so you can able to get each and everything in detail, in depth of it. So let me show you how many videos I have already posted. Here you can see uh, that kinematics 1, kinematics 2, and kinematics 3. These three videos have already uploaded, and every day at least one video you will see. So I will go and finish the kinematics. And kinematics, as you know, kinematics involve motion 1D and motion 2D. So for motion 1D, what I'm planning, at least 7 more video I will upload. So everything you will get in absolutely depth and detailed way. In that I have covered nearly all the books. So you not need to go through those books. You can only check these questions, and you can apply yourself to improve your concept clarity and the depthness of the topic. So let's quickly see the today's video and today's topic. So here we can see this is question number 1. Now a particle described the at an angle theta. Fine. The particle is described at an angle theta. Now here you can check the particle is starting from this point, and this is look like some curvical path it has obeying. So once we are talking about the velocity, so the blue line that look like the curve path, and it has started from point P. So point P, this is the initial velocity vector direction, is tangent to the path will going to give you velocity. This is velocity v1. Fine. With a constant velocity they were saying. So here I am keeping as v1, since magnitude is fixed but direction is changing, that's why v1 I have considered. And once it will reach at the point Q, so here you can see once again tangent, this is a tangent. Always remember tangent at a point will give you the direction of the velocity, that is v2. So these are the 2 point number P and point number Q. Change of velocity of the particle, this is part 1, and average acceleration of a particle during the motion of the curve. So these two things we have to calculate: average velocity and average acceleration of a particle during the motion. So as you know, average velocity once you have calculated, so average velocity divided by time, it will going to give you average acceleration for sure. So I thought the most important thing is how to calculate average velocity. So once again, if you are looking for average velocity, so average velocity at two different points, so it would be v2 vector minus v1 vector. This change of velocity upon time taken, that will going to give you the average velocity. Fine. So let's see the situation. Here you can see, and Let me quickly tell you, since it is a vector addition, here you can see this is a detailed diagram. You better to notice the diagram. So because the diagram seems to be play a very important role, because average velocity you have to calculate. Now for the sake of average velocity, we can say we have to first evaluate v2 minus v1. What is v2? v2 means this is my v2 vector. Fine. And the important and interesting part is the radius making angle 90, and here as well radius making angle 90, that is 90 with v1, 90 with v2. So what amount of rotation radius has taken, what amount of rotation radius has taken, the same amount of angle it will form between these two velocity vectors. So here you can see initial, this is the initial direction, this is the initial direction, and this is the final direction. So by what amount the initial direction get changed to final direction, that is the way the angle swap by a radius vector in the given moment, that is theta, the same it will be swapped by velocity vector from v1 to v2. This is important concept, we can say. Fine. Now here we can say we have to calculate v2 minus v1. So we will use simple vector algebra. v2 direction remain as it is. Fine. So let me draw you. Let me show, show you how to draw these velocity vectors. Fine. So this is v2, v2 vector. Fine. And v, this is the direction of v1 vector. Now v1 vector, now we have to calculate v2 minus v1. I told you in vector form we can write as v2 minus, in fact plus, minus v1 vector. In vector we used to add, not subtract, that's why add. So v1 we have to make minus v1 means we have to only swap the direction, that is minus v1 vector. Clear? Now minus v1 vector, once again this angle is theta, so this angle become phi minus theta. Now we will simply use law of parallelogram to calculate the resultant. This is the resultant, and what is the value of resultant? That is v2 plus minus v1. Automatically it is v2 minus v1. So this particular diagonal will give me v2 minus v1. Now we will simply use the vector algebra. So this is what it is shown. I thought resultant we will use the basic formula. V resultant is equal to under root v1 square plus v2 square plus 2 v1 v2 and angle between, like here the angle is cos phi minus theta. So cos phi minus theta we are keeping. So let's quickly see. So, so I thought it is clear to you. The basic formula would be under root v1 square plus v2 square plus 2 v1 v2 cos phi minus theta, and cos phi minus theta is equal to minus cos theta. That's why it will, minus will turn into minus, so that's why there is a minus sign. Now afterward we can say, since v1 and v2 direction change but the magnitude is same, That's why v1 and v2 we can keep as v. And afterward, how we calculate, let me show it to you. Now here it will become 2v square minus 2v square cos theta. 2v square, once you have taken common, 1 minus cos theta. Now here we will apply the cos theta formula. So cos theta has a three formula. This is a half angle formula. We will apply 2v square 1 minus. So 1 minus 2 sine square theta by 2. This is, but here it will going to be plus. Minus and minus get cancelled. 2 2s are 4. So ultimately it will become 4v square sine square theta by 2. So once we have taken from under root, it will be 2v sine theta by 2. So here we need some trigonometric expertise as well, and how we calculate this resultant. I thought this is clear to you. Now the next important thing is time. If we are talking about time, we can say time is very important parameter in kinematics. So please be very vigilant. The total distance. So speed is equal to total distance upon total time. What is the distance travel in angular path? We can say this is the distance, that is arc. As we know, angle is equal to arc upon radius. So what is this arc is? We can say this arc will be theta into r. That is arc. This is arc. So distance will be equal to arc. So time is equal to arc upon velocity. Since velocity is constant, we can keep as v. So t is equal to r theta upon v. This is the time that taken to reach from point P to point Q. So I thought this is clear to you. Now here we have delt theta time it has taken from P to Q. This is what we supposed to keep here, r theta by v. Now for average acceleration, we can say average acceleration means whatever the total velocity average, that's why the magnitude of velocity, it will be v only divided by time taken. So we have to only substitute these two values. Now once we substitute, here you can see, once we substitute v we have already calculated the magnitude. It is comes out to be, that is the average velocity delta v that we have calculated to v sine theta by 2 upon time we have calculated. Once we divide it, ultimately we got 2v square sine theta by 2. Fine. So this is the solution of the this question, and this is one of the very good question. It will going to give you the idea about how to calculate the vector addition. What do you mean by the term average acceleration? How to calculate the velocity change of the given vector once it will take in the angular uh, you know turn. And next important, theta, the angle made by the once radial vector is perpendicular to the velocity vector, to by what amount the radius will change, the same way velocity vector will also change between it. So that angle value that I'm talking about. So these are the important detail that you have seen. And now next I will going to bring you next problem, but not right now because this 14 minute already. So these are the question that I will just go and discuss you by short video form, so you can make it clear everything, because concept I will just go and discuss with you so you can able to explore the numerical, and my less number of numerical you can able to you know prove your self during the test. So I thought every question you better to sum up with important points as well. Like in the important point one here, what we have seen, how the theta we have taken between our vector. Point number two, velocity change, how we have calculated by using vector. Point number three, resultant, resultant vector, how we calculate by using parallelogram law. So for after every question, you better to just take and list some detailed bullet points. So it will going to help you further once you have come across these type of questions. So till then, take care. We will surely meet with next time with some next question. And I, whatever I instructed you, you better to just go and detail. And if it look like problem is good, so you can copy in your uh, you know copy it in your register or fair copy. Till then, take care. Have a nice time.